I've been lucky enough to have both the best day job in the world as a jet fighter pilot in the Royal Air Force and of course the best holiday job in the world driving world land speed record cars. And in both of those, timing is absolutely critical. For all aspects of flying jet fighters, from the precision timing of everything from starting the engines to takeoff to formation flying to meeting air-to-air refueling to counting out the number of seconds for air-to-air missile engagements, timing is absolutely dominates every single thing we do, and that's just looking at an individual airplane, never mind running large formations, coordinating with others, multinational across time zones. Everybody has to speak the same language, not just down to the same hour and minute, but down to the same second. In a very, very different way, timing is equally important for all forms of motor racing, and particularly for the ultimate, the most exciting and the fastest form of motor racing, which is the straight line motor race of the world land speed record. In its simplest form, a land speed record is a case of going from here to here faster than anybody ever has at any point in history. So it is simply a measure of time. There is a requirement to do it twice within 1 hour. So it's not just the nearest thousandth of a second from here to here. It's the average over those two and somebody timing that 1 hour. The clock absolutely dominates every single piece of aviation, every single piece of the world land speed record. It's fundamental to everything I do. When I saw the 444 watch for the first time, I had to pause for a moment. It wasn't quite what I was expecting. It was both simpler and more exquisitely engineered than I was expecting, because I'd already heard the brief about taking the various design touches from bits of the car and bits of Brooklands, and intrigued to see how they'd fit together. And the way it's been done, it's just perfect. It looks like a really, really slick, simply designed functional chronograph, and I love the functionality of it. And at the same time, taking a step back, it's also become a really, really attractive watch. It was a real thrill to see that. Having said, come on then Simon, show me your watch, to see the 444 for the first time was, wow, that is a nice watch. There is the most incredible link between Brooklands and the whole of British and indeed international motorsport. Right here on Brooklands, 1906, Hugh Lock King had a bet over dinner, one he probably regretted because it cost him a fair chunk of his fortune, that he was going to build the world's first purpose-built banked racetrack. The following year, 1907, Brooklands racetrack opened, and it was the first in the world, and everybody came here, not just from all over the UK, from all over Europe. And it was the racing drivers and the chassis manufacturers and the tyre manufacturers and the engine manufacturers. The expertise was all here. 10, 15 years later, end of the First World War, it was also Britain's largest aircraft manufacturing plant. So it also had all the aero engine manufacturers and the lightweight structures for aeroplanes and all of the design and testing expertise, including, critically, wind tunnel testing. And it was here in the archives in Brooklands many years later that the first evidence of land speed record cars going into wind tunnels was found, with some of Malcolm Campbell's designs. All of that meant that we finished up with all of this expertise in what we would now call the world's first aerospace and motorsport technology park. And it created a global centre of expertise here at Brooklands. And for the next, well, pretty much for the next 100 years, the Brits dominated the world land speed record, almost unbroken. Equally, they dominated all forms of track racing. And if you want any evidence that's still true today, Formula One is still based in the UK almost exclusively. All the world's best race car engineers operate out of the Vale of Oxford and work for the Formula One teams, and you can trace that heritage all the way back to this place in Brooklands. If you want to build a car that's faster than any other, either going round in circles or particularly going fast in a straight line, you are using the expertise in this country, which is second to none, world class. And the reason for that is because of Brooklands, because of the track in 1907, the aerospace expertise that was added into it. There is a very clear link, and everything about the land speed record you can trace back to the marvellous, unique opportunity that Brooklands presented us by being here. Instrumentation is incredibly important at high speeds, whether it be in jet fighter aircraft or indeed for land speed records. And let me give you a very simple example. When we were first looking at getting a car supersonic on the ground, the Jet Propulsion Laboratory at NASA was actually watching what we were doing back in the 1990s and told us afterwards that they reckoned getting a car supersonic at ground level was at least as difficult, if not slightly more difficult, than putting somebody on the moon. That's how big they thought the challenge was. We had a lot of Europe's leading experts advising us, and 2 or 3 of them saying, this is probably not going to work, it is too difficult. I was lucky to be part of an incredible team that said, yeah, okay, we do really difficult for breakfast, let's get on and find out how fast we can go. My task as the driver then was every single time we ran this car to test it to an exact required speed. So for instance, if we'd been to Mach 0.975 yesterday, so 720, 730 miles an hour, Mach 0.98 or 0.985 today, I need an instrument which can measure the difference of that very, very precisely to within 1 mile an hour, and that is airspeed. Don't care how fast the wheels are going around, it's all about the airflow and particularly the shock waves around the vehicle. So we've calculated the particular speed we need for the day, the Mach number we need for the day, and I then need to measure that incredibly precisely in the cockpit, literally to within 1 mile an hour or 2. Plus or minus 10 is no good. We'll either repeat what we did yesterday and learn nothing, or go too fast to a place where we're not yet sure what's going to happen. So that step-by-step precision testing, absolutely critical, and it actually comes down to a single instrument in the cockpit giving me super accurate readings. Why is that so critical? It's impossible to get super accurate readings in the transonic region, above about Mach 0.85, as the airflow starts to go supersonic, because you're comparing dynamic and static pressure, and the static pressure starts to go all over the place. You can't do it in aeroplanes. The computers have to process it and take a guess, but it doesn't matter quite so much in aeroplanes. In this car, it was critical. So we created a unique instrument that actually stored static pressure and only measured the dynamic and compared the two, and gave us the first ever truly accurate, smoothed Mach meter at ground level. That is the sort of precision that makes things like land speed records. For me, as a jet fighter pilot and as a land speed record driver, engineering function absolutely has to be top of the list. In terms of achieving very high speeds safely every single day, repeatably, and not just looking after me and my aeroplane, but looking after all of the other aeroplanes and all of the other crews, the engineering has to be able to do that. And that's a massive team effort. And there's a huge team of people that involves getting a jet fighter airborne, or indeed designing and building and running a land speed record car, which is equally dependent critically on the accurate, safe, reliable, repeatable function of the engineering. That said, there is the famous adage, which has been around for pretty much 100 years now, for aeroplanes: if it looks right, it will fly right. There is something about really good functional design of engineering that you can see with the eye, and it just gives you the shape that you're looking for. And you can see right away it's going to have a good function. There is something about good engineering that creates shapes that are pleasing to the eye. And that shouldn't be that surprising in a way, because shapes that are pleasing to the eye are the ones that ultimately we see in the natural world around us, and the natural world has had a long time to find the very best design features that make things like birds and fish and trees and all of the structures around us to make them work at their most efficient. And engineers who can capture that functionally in engineering are the ones that I enjoy working with the most, and you can see it in their design. If it looks right, it will fly right. If it looks right, it will drive right. It's just as true for motor cars of all kinds, including the high-speed straight line ones, and that is a great approach for any engineer to take. If you can achieve something that works really well and looks fabulous, you've achieved something really special. It's a popular misconception that you can feel high speed. Right now, standing here on the surface of the planet, the Earth is rotating, so I am doing several hundred, 600-700 miles an hour. If you stand on the North Pole, you're not going anywhere. If you're standing on the equator, you're doing 1,000 miles an hour, just going round. That's just the rotation of the Earth. I can't feel that. I'm just standing here stationary in a room. And it's exactly the same thing when you sit in an airliner. Sit there, you're doing 500, 550 miles an hour, but you've got some not terribly appetizing food in front of you, and if you're very lucky, a drink as well, while you go somewhere nice. You don't feel the speed. What you feel is the acceleration, how quickly you get there, how quickly you slow down again. That then becomes significant when you're doing bigger numbers than other people. In a normal road car, you get a small amount of acceleration, a fraction of 1 times the force of gravity, so 0.3, 0.4, maybe 0.5 g. Land speed record cars, particularly the modern ones, jet-powered supersonic car, you are looking at perhaps 2 g, 40 miles an hour per second, the equivalent of 0 to 60 in 1.5 seconds. And you don't just speed up that quickly. It takes 5 or 6 miles to get up to supersonic speed in something like the thrust supersonic car, when we set the record in 1997. And then having done a mile in 4.5 seconds, you have 5 or 6 miles of track left to slow down from 750 miles an hour back to stationary. So closing the throttles and putting the parachute out, you are then thrown forwards in the harness as you start to decelerate at 2G, which is the equivalent of losing 60 miles an hour every 1.5 seconds. And if you want to imagine that, I wouldn't try this on the way home, but if you want to imagine that, it's like driving at 60 miles an hour and coming to a complete stop in 1.5 seconds. That's quite a violent experience. And for a land speed record driver, that is a fairly normal experience. Now, I am lucky that as a jet fighter pilot, I'm used to that kind of performance, and I'm used to shutting out all of the superfluous distractions and the big G and the being thrown forwards in the straps and actually monitoring and controlling the vehicle. And I've been very lucky to be trained by the best and done that as a day job, the world's best day job, flying jet fighters, so I can bring that skill set to bear on land speed record cars. I am probably more in awe of the guys in the 1920s and the 1930s who were racing around the Brooklands racetrack, not experiencing that much G, but of course dealing with the corners and the bumps and the technology of the time and really pushing hard. To keep going with cars like that was a tremendously gutsy thing to do. And as racing drivers, they really were achieving something every time they thrashed their cars around these tracks. John Cobb was an absolutely remarkable individual. Very quiet man. He had been successful in the fur trade, so he was independently wealthy, did quite a lot of his own funding. He just believed in setting the world land speed record, as indeed did Campbell. There was an element of doing it because it was there, like climbing mountains, breaking the records simply because he could, and also an element of promoting great British engineering on a global stage, something we're still very passionate about today. Cobb was just an extraordinary individual, self-taught racing driver and land speed record driver, and taking that monster of a car, the Napier Railton, around this circuit at 143 miles an hour. And there is, of course, the classic picture of the Napier Railton with Cobb on at the wheel, with all 4 wheels off the track, because Brooklands, from the get-go, from 1907 when it was built, it was a bumpy track all the time. They never managed to get rid of the bumps. Nowadays, racing drivers would refuse to run on it because the car would just bounce all over the place. It would leap into the air. Cobb had to put up with that. That was the racing track of the time. That was where he set the all-time lap record here. It's an astonishing thing to do. There was an element of just needing to be able to get out there and do it. I was lucky enough to meet a group of school kids at Brooklands recently who were part of an engineering competition. And somebody said, what sort of advice for somebody who'd like to get into record breaking? And my advice to them was, absolutely, if you're thinking about record breaking, absolutely do not do it. Go and do anything else, don't get into it. It'll be harder, more tiring, more demanding, more expensive, take longer, just forget about it. But I didn't then have to add, however, if you're the sort of person that is going to break a record, you will ignore me and do it anyway, because you need the mindset of, yes, I get your advice, and yes, I know how hard, and I'm going to ignore all the challenges and just find a way of doing this anyway. And that is the essence of a record breaker. That is the essence of a man like John Cobb. I'm lucky enough to have spent a career flying jet fighters in the Royal Air Force, also to have had a fantastic career driving land speed record cars, most notably, of course, the thrust supersonic car, which still today holds the supersonic record. We've spent a lot of time putting the Bloodhound land speed record together, looking to try and find out if it's possible to get to 1,000 miles an hour. Now, one of the great challenges of any land speed record, and that goes all the way back to the 1920s, it's not just the car or the track or the team, it's the fourth element, the fourth leg of that stool is always the funding. And post-COVID, that has been a challenge. So Bloodhound, we may finish up being a COVID casualty, but we've still got some interest, some strong commercial interest. So we're hoping we will get Bloodhound out there and actually get to showcase great British engineering on a global stage, again, with a land speed record car. To remind ourselves in this country, we are still the best in the world at engineering and technology like this. To remind our young people that we are the best in the world and that the future for them, that high technology, low carbon, energy efficient world of the future, which where they will own and live in and build and maintain, that is the science and technology to do that is not only at their gift, but is also This is the country to be in doing it. We have such expertise in this country. With all of that as an option, it would be brilliant to see Bloodhound run and to showcase our expertise to the rest of the world. In the meantime, I've been hugely privileged to be able to come to places like Brooklands and remind people this isn't just a snapshot of 100-year-ago history. With the innovation workshops and the schools visits they've got here, it's also about telling kids how Brooklands of yesterday relates to the expertise across so many disciplines today, and gets them to look at all of the things they could potentially choose in the future. Having an idea of how we could take a 100-year-old mindset of taking the technology, the best in the world, and achieving remarkable things with it, and take it from now and project forward to how good can we make the world in the future, that's an ongoing mission for all of us. I think I've been hugely privileged to train as a mathematician, then to finish up with a career, the world's best day job, flying jet fighters in the Royal Air Force, and also have a fantastic holiday job driving land speed record cars. It's been a huge thrill and a huge pleasure, but more than that, it's given me a chance to be part of a team doing something that is world class, showcasing great British engineering on a global stage. Every time I do that, I get a chance to stand up and say, I am proud of what we as a team have achieved, of all the heritage that we represent, going back 100+ years to the early days of Brooklands and the great motor racing drivers, John Cobb and Henry Seagrave and the great Sir Malcolm Campbell, remarkable names that went before us. All of the technology of today, whether it be Formula One or aerospace, and all of the things that we are developing for the future. To be part of that story is a huge privilege. Why wouldn't I want to be part of that?